All right, good morning, everyone. Let's get started here. So last class period, if you recall, or maybe if you follow the videos, with the step that we ended up at was basically setting up our um, files and folder environment for today's class. So we finished the intro to our script, and then we started this 02 wrangling new, I guess, exercise in our folder, in our class folder or course folder. So if you right now I'm looking at my personal course folder. I see here that we have the 01 intro folder in here, which is the one that we used the files for the intro part of the course. And then last class period, we set up the 02 wrangling. So this, you should all have already done this step, where if you go into 02 wrangling, we have a R proj. So an R projects icon or file type here that sets up this this project. And then if you follow the instructions, you should have downloaded the um, the files from the GitHub repo, where you would have moved the partial code for data wrangling into the code folder of this project, and move the soybeans.xlsx data frame inside of the data folder of this project again. So, today we're basically going to be doing some data wrangling on a data set that is related to agricultural science. Is a study that we're going to talk a little bit more soon here. And I guess before we do that, I think I mentioned this already, maybe in a different class. I know some of you are taking my other class as well, and this is perhaps the last overlapping content that you're going to see. So if you're hearing this more than once, please bear with me, but this is really important to note. So we talked about RStudio projects and how that can be useful to manage different analysis and just different, projects, I guess, that you have in your computer. And as you switch from one analysis to the next, to make sure that you do that properly, every time that you want to launch a new analysis, please do so by first double clicking on that rproj icon to launch this project. So please go ahead and launch your RStudio environment by double clicking that 02 wrangling rproj, which should open up a new RStudio environment that is related to this specific project and the files that come with it, right? So you've done it correctly if you're seeing the name of this project or the name of the folder where it was created in on the top right. If you're seeing project none, you did not do it correctly. You need to make sure you open up through this project like this. One thing I've seen and I'm going to close here just to show you what one thing I've seen in the past is that if a student doesn't have any RStudio window open, or maybe they have one open already, sometimes students would come under the code and double click the code itself instead of opening the project icon first. And if you open RStudio by double clicking on the code file, it could open up in the wrong project. And you can tell if it is in the wrong project if you look on the right hand side. If it says project none, you're not in the right project. If it says a different project name, which you're going to start accumulating different RStudio projects in this course, but you open up a script and it comes out on the wrong project, please make sure you close this project, close this script, and go back and launch RStudio back again by double clicking on that RStudio projects file in the folder that you're working with that day or that moment. So again, I'm going to click on the 02 wrangling.rproj, which launches my RStudio environment focused on this project itself, right? So a quick reminder here is once you are in a project, the files tab becomes more important because now all the files related to this project are going to be focused on this files tab. So right now I am inside of the code folder. If you move this window around and you see that R blue button, let me actually increase the font size a little. And if you see that R blue button there, if you click on that, that takes you to the main folder of this project, which again, you have these on your computer, but this is how they show here in our studio for you. So if you click on that R blue button, you navigate to the code folder and you launch this script here, the 0112 data wrangling partial.r. Okay, so at this point, you should all be seeing this. So a few quick notes about this new file type that we're going to be using. So the first file type that we used was an R script for the intro to R, where everything that you typed in that script was fair game to be interpreted by R as you send that to the console. So that is a scripting file where you do all the scripting in that file, and then you send those lines into the console to be interpreted. Now we're going to be using, or today we're going to be using a file that has the extension .rmd, that stands for R Markdown. What R Markdown does, it is a literate programming scripting file. What that means is that it incorporates in the same file your narrative, code itself, and if that code produces any outputs, that output appears right below that piece of code. So this is an R Markdown file. Here, if you are in this area of the code here, you can write as you would normally in Word, for example. So this is an example of writing narrative on RMD files. So this, if you write up out here, you do not need to receive that by a comment. Anyone has a question online?
Yes. When I launched the code, it popped up a message at the top of the screen said package read Excel required, but is not installed.
Okay, so that's a great point. So R Markdown, I think maybe even R scripts files, if they notice you have a certain package that you're calling to use at some point in some part of that code, but it knows that you have not installed that, it will give you that message probably here on the top, I'm assuming.
Yes, sir.
And so if you, I think it has an option that you can click on like install or okay or something like that. If that appear for you, it just means that some of these packages we're going to be using have not been installed in your computer, and you're going to have to install them before we move forward. So I would say if you click on that, I think that message gives you an option to actually go ahead and install. So you can click on that button. If it doesn't, whenever we load these packages using the library function, if some of them gives you an error saying you don't have this package, really all we have to do is just do an install packages, and then it needs to open and close quotation marks, and you just call the package name. So let's say if you did not install read Excel, you just come here and say this. So I'm not going to be, I think if I remember well, read Excel was one of the packages that we installed in the intro to R. Maybe I'm mistaken, but I'm assuming that most of you would already have all these packages installed. If you do not, please go ahead and just do an install.packages on your side. That should fix the problem. Remember that install.packages we only use once. We don't install every time, but we do need to use the library function every time when we want to load a package. So go ahead and install it. If you do it like this, make sure you comment that off so it doesn't become active in your code for future exercises. Clint, if you have any issues with, or Clint, or really anyone, if anyone has any further issues with any part of the code, please let me know, because I want you all to be able to follow along, and having the packages installed is a part of that. All right, so just coming back here, quick introduction to our Markdown files. Yeah.
Can we, if we have to install this, can we install them all at once, at these columns and drugs? Type install very quickly.
So if you want to install all of them at once, you would have to use the C function. So I think it would be something like install packages, and then here would use the C function to concatenate. So let's say if you want to install read Excel, you would do read Excel and then comma, janitor. I think this would work. You can always do this if it becomes a lot of packages. I think I normally prefer to do one by one, just because if any of them gives me any errors, it's easier to learn which one is giving you errors and troubleshoot that way. All right, so just coming back here to our Markdown files. So our Markdown files are basically composed of just a scripting space that you can write as usual, like I just wrote this sentence here, and then is also comprised of chunks. So this is an important concept. It's a very simple yet important concept in literate programming. So a chunk is basically what starts by the 3 apostrophes, opening curly brackets, and then it sets up what language you're going to use within that chunk. In our case, going to be R, so that's why you see the R there. And then I'm giving this chunk a title called setup. You see how this chunk title is appearing on my table of contents on the side. If you're not seeing this outline or table of contents, you can toggle this outline button on and off, and you should be able to see it. You also will notice, well, okay, so the chunk we know it's a chunk because of the 3 apostrophes, curly brackets, R, and then closing apostrophes or closing curly brackets. And then you do some code in here, and then you need to close that chunk by using the 3 closing apostrophes here. I already left you, yes. No, that's okay.
I can't get it to install. I don't know, it says your attendee 0 link there.
Is that the read Excel? Did you do like install.packages, read Excel? Did you say something like that?
Yeah, I have that hash.
Oh, yeah. So if you have the hashtag in front of it, that basically deactivates that code. So what you want to do is just remove that hashtag and then have your cursor blinking anywhere in this line and just push command return. Did that work? Let me come take a look at it. So those online, just hold on a second. I'll be right back.
I got it.
Okay, nice. All right. Okay. So coming back here, so you are welcome to take your own notes outside of chunks. Again, outside of chunks, your code, whatever you write there is not going to be interpreted by R, so you're not going to get any errors. And then inside of the chunks is where R is actually working with you. So anything you run that's inside of a chunk is going to be interpreted by R. And you can notice how inside of a chunk, I am using the hashtag to create comments, right? And that's something we did in our script. So you can almost think of a chunk as your R script, right? It's just that now your R script is being intertwined with narrative and also some more text around things. And another part of our Markdown is that if that chunk produces any output, like a graph or a table, that output's going to appear right below the chunk instead of on the console, or even for a plot, that would normally appear on the plots tab here. Now with our Markdown, it's going to appear right below that chunk. And just a quick example here of why I also enjoy our Markdown files is that I'm going to create one. You don't have to create on your side, but if you were to create a new R Markdown file, we would come on new, or it could be file, new file. And you can see here, there are many file types you can create here. If I wanted to create an R Markdown file, I'm just going to give this, I'm just going to leave that name. I don't really care about what it is. Notice how now it opened a new one for me here. already has a chunk. I mean, it gives me basically a template to understand what our markdown is doing. So it gives me some text here. You know, it has a chunk for a summary of this data set called cars. So if I run that, notice how the output appears right below the chunk. And if I produce, and here it gives another example of a chunk that produces a plot. So if that chunk produces a plot, the plot will appear right below the chunk. So notice how you can interconnect your narrative, code, and output all in the same file. I think that's really useful, especially for scientific programming. Another added benefit here of our markdown files is that you can knit an R markdown file, meaning that it basically builds this file into some type of output. The default is HTML. So if I knit this, well, first I have to save this files to be able to knit. So I'm going to save on my code. If I knit this, it's going to basically to go through everything that's in this file and create an HTML report out of it, which is this right here. So we can see that all the text that was in that R markdown file is here, the code is here, the output is right below it. So this is if you start getting or start enjoying using R markdown files, you can basically write reports, and I know people that even write full papers just through R markdown. So if you create a file that's already organized from the beginning, then it becomes really easy for you to create a report, in this case HTML, that you can share with your PI or with your advisor, or maybe even for whatever you're working with. It becomes really, really simple. Okay, coming back to yes.
I was going to say, I'm assuming on that HTML file where it says untitled at the top, I'm assuming that's because like the tab at the top is untitled. Okay.
It's
like we could just change that to whatever we wanted it to be called.
So if you wanted to change, let's say if I want to change this like reports or quarterly reports, right? I would change that on the title here on this part of the code, and then save it and knit it, and that would update that title right there.
Okay.
Yeah.
Thank you.
Yeah. Okay, another piece of information here about our markdown files is that this top part of the code here is called YAML. It's just like an acronym YAML. It is its own language that is used for file metadata. So any metadata related to this file can appear on the top, and when you knit it, is going to use that. So you can see, for example, the title here is what's impacting what's coming out there. The date I have here is changing the date right there. And there are many other options in YAML. We're not going to be exploring a lot of them right now, but I just want you to be aware of it. So I always leave the YAML that it comes by default there. If I want to add more things, I do, but I don't delete what comes with it. And then really I work on the chunks and writing my code, and then writing any comments or narrative outside of the chunks. All right, I'm just going to close this untitled. It was just an untitled R markdown file. Is just an example of what that can do for us. And I guess one last thing for you to notice is if you are outside of a chunk and you use hashtags, this is not to comment things off. This is actually to create heading levels. So one hashtag here is a heading level 1 on your table contents. If you do 2 hashtags, that becomes a heading level 2. So you can see it's a little bit indented and so on. So this is helpful if you're preparing your file, especially to be knitted at the end. If you want to have like report at the end, these headings are automatically interpreted and gives you this heading level straight out on your HTML or PDF or Word knitted file, whichever format you choose to use. Okay, so that was a very quick intro to R markdown files. I just wanted you to get familiar with it and hopefully appreciate the differences between an R markdown file and R script file, which is the first one we created. So now, because the console really is not, I mean, it's still going to be working behind the scenes, but we're not going to be using the console to really see what's going on, because whatever we print is going to come right below that, each one of the chunks. You can go ahead and minimize the console by clicking on this button. And let's get started with today's exercise then. Every time I do any analysis, one of the first things I do, regardless if it is in our script or in our markdown file or whatever other file, it may be a Jupyter notebook, I always like to first have a piece of code where I load all the packages or libraries that I'll be using. So here you see that I'm using the function library to run or to load multiple packages here. Read Excel is a package that's going to help us to read Excel files into R. Janitor is a package to clean data. You're going to see soon what that does. dplyr and tidyr are for data wrangling, and readr, we're going to be using that to export a CSV at the end. Another tip here is a little bit, so if you remember from the intro to our exercise, if you had your cursor anywhere in a given row of the script and you push command return or control enter, you would run just that line of code and move your cursor to the next one in a way that you can really go incrementally one by one if you wish. If there is a chunk of code that you want to run the entire chunk all together, you can come here on this play button and just hit that, and that's going to run all that chunk together. This is helpful if you have code that's working. If you have code that is not working currently, then it's better to run line by line and then really see where your error happens. Here, this code is working, so you can please go ahead and run the whole chunk. You should already have all these packages installed. If you do not, you already know how to get them installed. And I'll leave that for you to do on your side. If you need a little bit more time, please let me know. All right, I'm not hearing anything, so let's keep moving. So the first thing we're going to do here, or I guess the second thing we're going to do here, is to read in the data that we're going to be using today. So if you recall, this data is in the data folder, and it's called 02soybeans.xlsx. So that is an Excel file. Let's go ahead and read that data here and save it to this object called soy_k. So let's go, please start coding with me here. So let's use the assignment symbol. And because this is an Excel file, we're going to use the function read_Excel. Every time that we are using or that we're trying to read something into R or export something from R to file, we need to use paths, right? So computer paths. To do that here, we open and close quotation marks, have your cursor blinking in between the quotation marks and hit tab. In your case, it may already complete this and give you the 0112 data wrangling partial RMD because you have only one file in your folder. Because I created this untitled RMD to show you just previously, I have a few files, and because I have a few files, it gives me the option to choose. The problem is that really our data is not here, because right now our cursor thinks or is seeing that our path is inside the code folder, and our data is in the data folder. So we need to get outside of the code folder and then go inside the data folder and bring in the data. To go outside of a folder or to move one level up in the folder hierarchy, we use .. So if you just type that, you're going to see that it's going to show you now the contents of your main project. And then you can just here click on the data folder. And then if you hit tab again, it will already autocomplete the 02soybeans Excel file because that's the only file in that folder. If you had more files, it would give you the option to choose them. If you're able to do this, you should be able to run this. I would say do not hit the play button, just run this line individually. So have a cursor there and then push command return or control enter. If it doesn't give you any error below, then you're probably safe. And you can notice how in your environment now there is an object called soy_k. Was everyone able to load their data successfully? If you were not, please tell me because you will need to have it loaded to be able to work today.
I am unable to do that.
Okay, is it giving you an error?
No, it is not at all giving any error. In the semi quotation, I am unable to, that is not auto suggesting me anything.
Do you have your, are you in the right project? Sorry, I can't hear you. You're muted.
I am in the right project, yes.
Okay, and when you go to your computer files, did you move? Well, let's do this. Let me stop sharing, and then you can share your screen and we can troubleshoot together.
Yeah.
Oh, sorry, let me give you permission. All right, go ahead.
Sure. Can you see it?
Yes. Okay, so what happens when you hit tab right there? Okay, yeah, so that's happening because right now you are in the code folder and that folder only has one file. So you need to get outside of the code folder. So you can go back to the code part where you just hit tab.
Yeah.
So delete that RMD, all that, and just keep delete all that and just keep the quotation marks. Yes. So now press .. That takes you up one level on your folder structure. Hit tab now. All right. So now you are at the main folder. Now you go in that data folder and then hit tab again. That's your soybeans. There we go.
Okay.
Now, if you run that, it should appear in your environment and you should be good to go. Yep.
Okay. Thank you.
Yeah. All right. Anyone else having issues to import the data?
My one is not working also. I could find the problem here.
You could or could not?
I couldn't, sorry, I couldn't.
Okay. Do you want to share your screen?
Yeah, sure. Okay, are you able to see?
Yes.
So
Okay.
every time I run this line, nothing happens.
Okay. So actually something, let's see. Okay, so for some reason, so if you see, it is running the chunk, so it's almost
Yeah.
like it's frozen. What I would say is try to restart your RStudio, I guess. Like if you just close the window, you may have to force quit because it seems like
Like save or not? Just
yeah,
save?
you can click save and see if that closes. Okay. So yeah, just try opening your RStudio again. For some reason, it seems like your chunk was stuck. So maybe it was because of a previous run.
Oh,
that-
let's see. Yeah, I got the same issue again. I don't know why I stopped this.
Can you share your screen? Okay, so maybe it seems like it's given us. Well, okay, so what if you first run that first chunk that loads the packages?
Seems that everything's going well.
Okay, so now try to run that soy K line. Let's see what happens there.
Do you think it can be because my R version, probably is like,
I think it
something-
could be that if
they're gonna install it again.
yeah, it may be related to that because you see that all the packages there are telling you that
Yeah,
they were
probably
built
that's the
on a different
problem.
version. So if you have an older R version, that may be the reason.
Yeah, let's keep it going. You're gonna just restart it because I had Excel before the class, so I thought it would work, but
Yeah,
probably it doesn't.
yeah, maybe it's because of the R version. I would assume.
Yeah, okay, thank you.
Yeah, I think that's going to be something hard for you to troubleshoot right now and keep following the class, but you know, we have the recording afterwards, and if you have
Yeah,
any-
I'm gonna pay attention and try to do my best here.
okay, awesome. All right. Anyone else having issues to load this? Yes.
Maybe we go 2 files down, like suppose inside code, we have a folder script,
Mhm.
then we have RNG file. And we duplicate outside of the code.
Okay, so let me just share my screen here so everyone can see what the question was. Okay, so Ujwal is asking, so if you have more folder structure that you need to navigate. So let's say, so normally you want your files to be within this project, right? But let's say, I'm just gonna delete here just so we all can see. So if I needed, so right now, if I don't do anything, in my path is inside of the code folder. I want to get outside of it, right? So do // to see the main folder or the main project folder. If for some reason I wanted to even go a level up, I could do again // then I'd see my main folder of the course, and you can just keep going, right? So I start seeing other folders going up in my file system. Normally, we want to avoid that. We want to have all the files needed for this project to be within this project. But let's say maybe in code, maybe you had other subfolders inside of code, right? So let's say if I come here on code and I create a subfolder called, I don't know, like R script, or yeah, R script. And so let's say now I have this new folder here, and if I navigate here, I have that as well appearing right here, right? So you can really navigate easily by learning the two tricks of how to go up in hierarchy by doing // and then hitting tab whenever you get there to show you the options of what you can fill from that point. Okay, let me delete this and just keep going. So as a reminder, you want to do // you want to go inside the data folder and then have the soybeans XL as X. All right, so I imported this. I just want to print it on my, in this case, right below the chunk. So if you just go ahead on that soy K and you run it, it's going to print this data frame for you right below the chunk. So notice how now it is not on the console, it is right below the chunk. Let me decrease the size here a little bit so we can see more. So on this data frame here, we have, it is a tibble. If you remember this conversation, tibble is just a data frame that prints nicely for us. So it has 16 rows, 8 columns. We see here there's a plot number column, a treat number column, a crop stage column, a potassium rating pounds per acre column, and then some measurements that were taken in 4 different locations in Georgia on a soybean trial. So this study here, just to give you more context, it was a study. It is a fake study. It is true data, but the way that I put together is not an actual study conducted in Georgia, but just for us to kind of play around with that. You know, it is a supposedly soybean study where we were running that in 4 locations. So Tifton, Midville, Watkinsville, and Macon, where we wanted to assess the effects of different potassium fertilizer rates on soybean trifoliate or potassium concentration. And each one of these studies was a randomized complete block design where the treatment design was potassium rate with the levels of 0, 50, 100, and 150 pounds of K2O per acre. Also, just a quick note here, whenever you're printing a data frame in R Markdown and that appears right below your chunk, notice how it kind of wrapped around to make it fit nicely in your screen, even though you may have extra data that is not showing up right there. So if you have more columns like we do, you would click on that right arrow on the top to navigate those extra columns. And if we have extra rows that are not appearing here, you would navigate through this index here in the bottom to see the bottom rows. All right, just a quick function here that I want to expose you to is the function view. So if you're missing, you know, the way that data looks on Excel, you can use this function view and give it the object name. So soy K is the name of our object. And that pops up a new window for you. It's not exactly like Excel, but it gives you a more of a tabular view of everything that you have, and it pops up as a new window as well. So I just wanted to expose you to that function. I sometimes use that on my side. If you want to go ahead and close that window, let's just keep moving here. Another function that I use commonly in R is this function called glimpse. So if you want to go ahead and type glimpse lowercase and then say soy k, that's our object. And if you run that, this is what it prints. So it tells you how many rows you have, how many columns you have, each one of your columns, and then how R is currently interpreting them. So you see that everything except stage. So stage is considered a character because it has a letter in its levels, R4. So it is a character, but everything else is being considered as double, or this also means numeric, right? So everything is numeric except for stage, and then gives you the first few entries of each one of those columns, which can be a good way to get a glimpse of your data. Next, if you go to the next chunk here, let's explore the function summary. So we already talked about this function, where if you just come here and type summary and give it your object name, soy k, it will print you a summary of each one of those columns. For columns that are character, in the case of stage, is not very useful, I guess. The summary that it gives you just says the length, so how many rows there is. But then everything that's considered numerical, it gives you a statistical summary that includes the minimum, the first quantile, median, mean, third quantile, and maximum values. This is really useful as a first quick look at your data, because the more complex data you start collecting and using, the harder it is for you to just look at the data, even in Excel, and see if everything looks right. So here it gives us a quick summary, and so let's say I know that my potassium rates in pounds per acre are within 0 and 150, because that's my design. If I come here and there's a negative minimum, or maybe there's a maximum that's above 150, I know that was probably an entry error, and I can catch that soon, change that, and make sure that doesn't impact my analysis moving forward. Same way with potassium concentration on trifoliates. These are in percent, so like ranging from, let's say, 0.6% in Macon all the way to 3.35% in Watkinsville. So if these values are way higher, or even if you have negative values in these columns, that's also a red flag that you may have had a data entry error, or maybe an analysis, like a lab analytical procedure that was not done properly, that you have a value that is not biologically possible. So the summary function helps us with that. Okay, so now let's actually start with our data wrangling process here. So data wrangling is really the process of transforming and adjusting your data so it is in a tidy format. So tidy format means each observation is a row, each variable is a column. That's the easiest format that we can have in any programming language to easily do plotting, analysis, and so on. So let's wrangle this data here. So the first thing that I'm just going to want to print soy k here right below, just so we take a look at soy k, the original data set again. One of the things that I dislike about this current data set is that if you look at the column headings or column names, they are really not standardized, and they have some issues as far as what type of characters they include. For example, the first column here, plot, has P uppercase. The second column, treatment, has everything uppercase. The third column, stage, has everything lowercase. So that's all non-standardized format. And then if you come and look at our potassium rate column, there's a couple issues here. One of them is that there are white spaces. This is really difficult to program with because white spaces add extra coding for us to be able to use this column when we need to reference it. And also it has special characters because it has parentheses. So all of these are things that may come in your data sets when you bring them in, but they are problems for you when you start actually working with this data. Now, here we just have 8 columns, but now imagine if you have 100 columns, which is really not that uncommon these days. And you have all sorts of different types of column names being used here and with different formats, it really becomes a pain if you will need to change them by hand. So we're going to use this function called clean names that's going to help us with standardizing all this. So if you come here, let's use the soyk_1 and save our results to that. So if we come to this part of the code, to give it the assignment symbol, we're going to use this function clean_names that comes from the janitor package and just give it our initial object called soyk. So remember, soyk is what we read. Now we're we're applying clean names to it and saving the results of that to soyk1. So if you run that and you print it, so if you print soyk1, which again has just been through the clean names function, notice how now everything is lowercase, so it's been always standardized. Anywhere that we had white spaces have been replaced by underscore, so using this log concept, and then all special characters were removed. So notice how now the parentheses are gone, and everything is nice and formatted in a way that's really easy to refer to these column names whenever we have to. So clean names is really a very useful function as you start working more with your, with different data sets that come in with different formats for column names. All right.
Something different happened in mine.
Yes. What was it?
It just give me let me see. So soy K1 clean names. It removes when I print it removes the table.
Removes the table.
Yeah, it took it away. I don't know.
Let me allow you to share a screen. So
Yes, sir.
that's what you're seeing.
You see it?
Okay, so what happens if you run line 47 and 49?
Together?
I mean, you can run them like one by one. So by doing command return or control enter.
Okay, command return. That's
Mhm.
what happened.
Yep.
And then
now
run this one?
Yep.
I'll put the cursors right here or just from here?
Wherever in that line it works. Yeah. So
It works.
where it
Okay.
is now should work. Yeah. No, you got.
Okay. Okay.
Yeah, I think you just had to print it. Yeah. So the on row 47, you're applying the function, but if you want to see that actual object, you need to print that at that point.
Thank you, sir.
Yeah, you got it. All right, let me start sharing mine again. So the next step here that I want to do is, let's say if for some reason I wanted to only filter some rows here. So we saw how to do some filtering in intro to R, and I told you that was going to be probably the last time that we're going to see how to subset a data frame using the bracket notation. So here I'll show you the function filter. So filter we use when we want to filter rows. So let's say I only want the rows that have a given condition, right? So let's do that here. And before we do that, I want to expose you to this function called names. So if you run that name, soyk1, it basically returns you the names of the columns that you have right now. Remember, we're looking at soyk1, so it's already been through the clean names function. So these are our function names, just as a reminder for us. So please come here on soyk_2, give it the assignment symbol, and let's use the function filter. So the first argument here is always going to be the data frame that we're going to filter from, which should be soyk_1. If you give it a comma and just hit return to break the code and make it easier to read, now we give it the condition. So I want to give you a specific condition here, which is to filter only the rows where the treatment potassium rate was equal to 0 pounds per acre. So if we come up here, that column is called potassium rate pounds per acre. So you can either copy from here or copy from the names that we just printed below. So we're going to say potassium rate pounds per acre equal sign 0. So Notice how I'm using 2 times equal sign here. That's because this is a Boolean operator. So a Boolean operator is any operator that is going to help you to do these types of conditions, like it's equal to, is different from, it is greater than, is smaller than, things like that are Boolean operators. And here it is a condition that we're given. I just want the rows that have a potassium rate of 0. If you go ahead and run that, and then remember to print the result by running the object name, notice how now we only have 4 rows, and those are only the rows where potassium rate was equal to 0. This filter function here, even though we're using a very simplistic way, it is one of the most important in the toolbox of one of the most important data wrangling functions that you're gonna need to use for any project, really. So I just wanted to expose you to that. All right, so let's go to our next chunk here. Next, what I want to do is, our treatment here is in potassium rate in pounds per acre. Let's say you're preparing, a manuscript or a presentation or something that you need these units to be in international units. So we need to basically transform that pounds per acre to kilograms per hectare. Every time that we want to create a new column here, you should be thinking of the function mutate. So mutate is going to create a new column for you. So what we're going to do here again, I want to save the result of this next chunk on this object called soyk_3. So you give it the assignment symbol. Let's call the function mutate, open and close parentheses. The first thing you give it here is, again, the data frame name. So we could go ahead and use soyk2, but I do want to actually have the entire data set and not just the potassium rates equal to 0. So let's instead use the soyk1 that has all the rows, but it has been clean names already. So mutate soyk1, I just add a comma, and I want to add a few code breaks here just so we can see better, make our code more readable. So currently we have this column called potassium K_rate_pound per acre. Let's create a new column here that we're going to call K_rate_kgHA for kilograms per hectare. So this is the name of the new column that we're creating, or mutating in this case. And now we need to say how we're going to create it. So we give it 1 equal sign. And this is because we just want to say that this function is going to be whatever comes on the right side of that equal sign. This is not a Boolean operation. We're not trying to filter or do anything conditional that will, only give you a subset of the data. So that's why this is 1 equal sign. This is 2 equal signs. So this is basically going to be our potassium. So K_rate_pound per acre. It's going to take that column and then just apply a formula. So that is, you multiply that K rate pounds per acre by 0.454 and divide that by 0.405. So this is the formula to go from pounds per acre to kilograms per hectare. If you go ahead and run this piece of chunk and print what soyk is going to show you the data below. You're going to have to click on that right arrow button to see the column, because the one that creates it puts last. So here it is, our potassium rate in kilograms per hectare. One thing for you to notice is that this column has many decimal points here, right? So it has many spaces after the point here. And this is really not what we need. It's not really useful to have this specificity on this column. I really just want to know 0, 56, and so on. There's a few different ways we can fix that. I want to show you one of them. So if you come here right after the 405, you add a comma and you hit tab. Let's just create a new column that is going to be called exactly like what we just did. So K_rate_kilograms per hectare. In this case, we're basically overriding. So we're going to be overriding the first K rate kilograms per hectare. And what we're going to do here is say equals to, and then there is a formula called round. So this formula here, as you would expect, rounds a number for you. What we want to round is the original K rate, kilograms per hectare, give it a comma, and then you say how many decimal points you want to round it to. I want to round it to no decimal points, so 0. So this is what it should have. Remember that you need to have a comma here after this line of code. This column name is the same as that one above. We're using a function round where it has a comma and then an argument 0. So now you close the parentheses of the round function, and you also need to have a last closing parentheses that closes the mutate function. So again, always keep an eye on these things as far as having commas in the right places, opening, closing parentheses. Those are some of the most common quick issues that people have with coding. If you run this and you print soy K3, and then you browse the last column, now we have a potassium rate, kilograms per hectare column where our rates are integer numbers instead of fractions as before. All right, cool. Now, I just want to take one moment here and ask if anyone needs help.
Okay, can you go back just like a little quick for the soy K1? I could restart my R, now it's running well. I just missed the soy K1 script.
Yeah, nice.
That's pretty easy one. We're gonna take a print screen here. Okay, thank you. I'm gonna start to run everything again and see if I can get it.
Awesome, good deal. Let me know if you need a refresher or anything else.
Okay, thank you.
Okay, so next thing I want to do here is whenever we're going to run a statistical model, which is, is one of the reasons I guess we're collecting data anyways, is to learn something by running stats on the data we collect. One of the things that we need to have is, at least for this type of data, is the block number, right? So this was a randomized complete block design. If you don't know what that means, don't worry too much at this point. Just know that these plots were randomly assigned to different blocks, and we need to have a column that identifies those blocks for us. So if we just print soy K3, if you're starting in plot, treatment stage, the potassium rate, and then the measured trifoliate concentrations, that's what everything we have. We do not have currently a block column, but we need that. We need to create that. Anyone has any idea of how can we use the current data we have to create a block column? Any guesses from the online students? Is there a way we can extract the block information from any of the columns that we currently have? So using $sign could be a way to perform the action, but we need to use one of these columns to learn what the block number was. I guess I'm trying to get at that, like what column here could we use to learn our block number? Okay, so yes, go ahead.
No, I was just gonna say the plot, maybe.
Okay, the plot. So so Rolando, how do we learn block number from the plot column?
I don't know how to explain this, but maybe parentheses, and there will be one double points to the last plot, for instance, maybe to bring it in parentheses.
Well, I mean,
I don't know if that
you don't have to think in coding terms, just like if you were to explain to me just in words, like, I can learn block here using the plot column because of,
So the idea is you want to create a column that it will identify each plot. That's what you're saying, right?
each block, right?
Each block, okay.
So I guess Ujwal was about to say something as well. Ujwal, how do you think we can use plot to learn about block?
So one block number is one treatment, so, 105. The plot number that starts with one can be put on the one block, like 105, 102,
Yes,
and then again, second block is 2 or 3.
yes. So Ujwal got it. Let me just rephrase that for those online. So Ujwal was saying basically that plot numbers that begin with one, so the hundreds would be block one, and the ones that begin with 200s would be block two, and so on. And that is where I wanted to go. And maybe this is not as clear depending on what type of research you do, and even if you've been doing research altogether yet. But I just want to quickly make a drawing here to show you all what some of the things I mean by that. So the way that normally works is, let's say if you do even a field study or a greenhouse study, you would probably have blocks. So this is not very nice, but it's not a very good drawing. But imagine this is a block that would be like block one. And then here you have plots inside of it, where each plot is a random treatment that you assign to this. So let's say, we would have here the 0 potassium, this would be the 150, this would be the 50, and this would be the 100. And then I guess those are all treatments we had, so we really don't even need this last one. So this would be block one, and then you have 4 times this. So block 2, 3, and 4 are similar versions of this. And normally the way that people name things in the field is they would name this first plot here 101, this would be 102, this would be 103, and so on. So using the plot column, we can actually infer the block number by that first number of the plot number, right? So this is just the idea behind here. And, again, if you have not done this a lot, maybe that was not as intuitive, but this is the intuition that we're coming after from this point. All right, going back to the code. So let's do that. So basically we need to create a condition, right? So we need to say if plot number is between, or is like between 100 and 200, then the block is block one. If plot number is greater than 200 and less than 300, then block is equals to 2, and so on. So there are a few ways we can do that in any programming language. One of them is using multiple nested if-else statements. That becomes, if you ever done, I'm not going to do that here, and I'm going to show you why that's not a good idea. But if you've ever done that, even in Excel, you know how it starts to get really complicated to understand what that if multiple nested if-else statements even mean, because you have so many things nested that it becomes a hassle. And it is actually still an option in R, but there is a better way of doing that I want to show you here. So let's come on soik_4. Let's give it the assignment symbol and create the mutate function, since we're going to be creating a new column that, if you remember, the first thing we give function is data frame coming in. So the data frame coming in is the soik_3. Give it a comma. Let's just break the line to make it more readable. And then I want to call this block column as rep, actually, for replication. So in this case, block and replication mean the same thing. And this is where I will start giving it some conditions. I want to do that inside of a function called case when. So if you type here case_when, open and close parentheses, and let's break code again, just to make it easier for you to see the conditions we're going to give. So here we're going to say, when this condition here is true, then the rep column is going to receive a value of X. So let me show you the first condition here, and then I hope you can develop that intuition of how this works a little bit better. So right now we have this column plot, and we're going to be using that column to give our condition based on that. So we say plot. What I want to say here is that if plot is greater than 100, then we use the tilde symbol for that. For those of you that don't have this on your keyboard, especially if you're attending online, I'm going to post that on the chat so you can copy it. Right, so we say if the plot value is greater than 100, then the wrap value is going to be equals to 1. Okay. Let me try to run this and see if it works. Okay, it did work. So if you just print soyk4 now right below it, so we have here plot, so 105, 203, 305, and if we go all the way to the right, now we see the wrap. So it should be 1, 2, 3, right? But we have everything as 1. Why is that? Why is everything set to wrap to be 1?
Because you didn't specify that if it's 200, it will be plot 2. So everything after 1 will become 1.
Yeah, so basically all plot numbers are greater than 100, right? So first on this condition here, I have to specify an upper limit of this condition. I just gave the lower limit, but I need to specify the upper limit of this condition. So if I want to give two conditions in the same statement, I just add a and symbol. This and is like that. And then I need to say plot less than 200. Right, so now only for plot numbers between 100 and 200, I'm going to call them 1. Or block or wrap 1. Let me just run this and see what happens now. Okay, so now it kind of worked, right? Because now everything that was 100, and maybe you're not able to see, but if we just go back to the first page, so 105, 203, 305, 401, 102, so 1, 2, 3, 4, 5. So rows 1 and 5, for example, are plots hundreds. 1, 2, 3, 4, 5. So it did correctly, right? But then, because it didn't give any other conditions, it just filled everything else with NAs. So now to give more conditions here, we just add a comma. I want to hit return just to break the code a little bit more. And I just want to create the next condition for block 2. So now I want to ask for some help here since you've seen how it was done the first time. Renelisa, what do you think?
So for block 2 is for using block and breaking 100.
Mm-hmm. Two. Yes, perfect. So Renelisa was speaking here in the room. Maybe you have not heard if you're online, but she just said basically what I typed. So for rep number 2 is going to be plot number greater than 200, and also plot number less than 300 is going to be block 2. If we just go ahead and run that and then print it. So 105, 203. If we check, it should be 1, 2. Okay, cool. That's making sense. So now we just need to go down the line here and complete for the rest of it. We did have 4 blocks here.
Hey, quick question.
Yes.
Okay, there where you're putting the 100 to 200 or 200 to 300, like you're setting the range, would you, instead of saying like for rep 2, 200 to 300, would you not need to do 201 to 300 so that there isn't overlap there?
Yeah, so that's a good question as far as the overlap there right there. So right now, let's say if we did have a plot number that was exactly 200, right now that plot would not be considered here, right? Because if you see the 200 itself is not, there is no equal less than or equal greater than at the 200. That's a great point, because in our case, that's not going to be an issue with this data set, because plot numbers are starting from the hundreds and 1. So 101, 201, 301. But if it did have this condition, like let's say if we had plots like on the hundreds, like 100, 200, 300s, we would have to give an equal sign somewhere. In this case, it would probably be on this second one here. Or so let's say we could say greater than equals, like that. So this would make sure that if it is greater than or equal to 100 or 200, then it would fall inside of that rep. And that's a really great point, because this, again, if you remember, this is a Boolean operator again, right? So this is saying if plot number is greater than or equal to 100, or plot number is less than 200, then this happens, right? So this is how you would have that overlap and not have any numbers missing from that condition. Yeah.
Okay, thank you.
That's a great point. Thanks. All right, so we're just gonna keep going down the line here just to finish for the remainder of the plot numbers. So I want to add a comma, hit return. So the next one here is going to be if plot is greater than, and we can say greater than equal to 300, and at the same time plot is less than 400, then the wrap equals to 3. Add another comma there, and then lastly, this is a simpler one. I can just say if plot number is greater than or equal to 400, then wrap equals to 4, right? So this is how you would, because 400 is the last level we have, we don't have a 500s here. We can just say that, and that should work for us. I just want to, so this is how you would, this is it's a very simple case that I'm showing you here, but this function case when I use it so much in my data wrangling activities, and that's why I'm exposing you to it, and to the logic of how to use it, is because you will have to use conditional statements when you're doing different types of data wrangling, and using case when makes your code very readable and understandable as compared to multiple if-else nested statements. If you go ahead and run this, if you had everything correct, so one thing to notice is if you had, so the equal, when you're doing greater than equal to, the equal sign has to be on the right side of those two. If it is on the left side, it throws you an error. So just a reminder here, have it on the right side of those two operators. Make sure your commas are in the right place. Make sure you have all their parentheses closing properly as well. It should work on your side. If you print it now, soy K4, and you move all the way to the right, now we have our block information 1, 2, 3, 4, 1, 2, 3, 4, that is based on our plot number, right? So this was a very, imagine like if I mean, of course you can use if-else statements in Excel as well, but it would be probably a very lengthy, not very interpretable statement in Excel to make multiple if-else statements. And also this way is very clear what condition we're setting and what's becoming if that fulfills a certain condition. Okay, any comments or thoughts at this point? I don't hear anything, so let's keep going. Okay, this next one here is a very, very cool one that I'm sure you're gonna run a lot into these types of situations. And I just want to show you how to kind of fix that. So if we just look at soy K4, which is our latest version here, if I want to run a model, like an analysis of variance model that incorporates location as one of the factors of that model, or even if I want to make a plot where I want to color things according to location, I need to have a column here that has location as the title, or I mean, the title doesn't have to be location, but I'm just proposing a title here. The title of the column should be location or something like that. And under that column, I should have Midville, Watkinsville, Tifton, so on. We do not have that. We do not have a column right now that has a location information under it. So let me stop for a moment and ask you all, maybe somebody that hasn't helped me yet. Where is in this data frame, where is the location information at right now? Send us. What do you think? But where is it? Where is the location information right now? If you explain to me, where is it right now? So you're correct that Midville, Watkinsville, Macon, those are the locations that where those were collected but where are they in this data frame right now? So they are in the column headings, right? They are in the column headings. And if they're in the column headings, I cannot use them to run a model, even to make a plot if I want to color, let's say, lines according to location. So this is a concept of tidy data, right? So right now we have our location information is in the column headings that is not tidy. It's not in a format that we can easily use for anything in an analysis setup. So we need to bring them into one column only. So that's what we're going to do next on this next chunk here. So we're going to use this function called pivot longer. So come with me here on soyk_5. Let's use the assignment symbol. This function pivot longer, I guess before we do it, I just want to tell you what it does. So we're going to tell it that we want to pivot longer all these columns that have the location information and the trifoliate concentration in them, right? So that would be Tifton, Midville, Watkinsville, and Macon. So what's going to do is take the values of each one of these. So we have 4 columns right now. It's going to take the values of each one of these columns, and instead of having them going wide or sideways, you're going to stack them under each other. So take all those values and stack them below each other under a new column that's going to only carry the values. So the potassium concentration in this case. However, if we only did that, we would not know where those values were coming from or what were the original columns that they were under. To fix that, it's also going to create another column that's going to call something like names or whatever name we want to give it. And it's going to repeat Midville KPCT 16 times, and then Watkinsville 16 times, and then Macon 16 times. So now we're going to have 2 new columns where one of them is going to carry the values that we're seeing right now, and the other one is going to carry the repetitive name of the current columns under that new column. If this doesn't make a lot of sense right now, just bear with me. We're going to go through this, and it's going to make sense in a second here. So come on soyk_5. Let's use the function called pivot_longer. As always, the first thing we give it is a data frame coming in. So that is soyk_4. Remember, that is the one just above where we just created the wrap column. And now it has a few arguments here. So then the first one is names2. So this names2 argument is basically saying, what is the name of the new column where the current column headings are going to go to? So I want to say names2 equals open and close quotation marks. I want to call this location.k. So a new column called location.k is where the names of the current columns are going to go under. If you give a comma here, hit return again. There is another column that it says values_2. So this is the name of the new column where the values are going to go under. So I want to call that, if you give it open and close quotation marks, I want to call that K_PCT. So this is where the actual potassium trifoliate concentration values go under. And then finally, well, if we do this, you can just go ahead and run this. Actually gave us an error. And the error is that we must select at least one column to pivot longer. We did not select any column of the current data set yet that we want to do that. So we come here, add a comma, hit return just to break the code. And then it has this other last argument called cols for columns. So here is where we give the name of the columns that we want to pivot longer. What we could do is simply, come here and starting with Tifton, Midville, Watkinsville, and Macon, just give them as using the C function and just give them like that, like this. So, if we just say Tifton and then the next one, it's going to be Midville and so on. We can do that. But I want to show you an easier way of doing this. So I will share with you a cheat sheet for data wrangling later that you're gonna see a lot of the types of functions that we're using. And one of them that makes things a lot easier here is instead of giving multiple column names in this case, we can use this function called contains, which is a helper function from the tidyr package that we can give it a pattern and it will match that pattern to any current column names and only select those columns, in this case, to pivot longer. So if you notice, Tifton KPCT, Midville KPCT, Watkinsville KPCT, Macon KPCT, they all have this pattern of containing the characters K underscore PCT. And no other column that we don't want to pivot longer has this pattern. So only those four. So what I can come here and do is say contains, open and close quotation marks, KPCT. So it's going to look for this pattern of any column headings containing KPCT in their name and only pivot longer those columns. So if you run it, you should be fine working or running it. If you print it, now see what happens. Now we have a table of 64 rows, right? Before we had a table of 16 rows. What happens is that we had 4 columns that we went from wide to long. That means that we basically had 16 original rows times 4 columns that we pivoted longer. That gives us 64 new rows. And that's where SOIK5 is. Anyone online has a question?
I got an error when I run it.
Yeah, what is it saying?
Error object soiking not found. SOIK4 not found.
So what I would do is make sure that this object coming in, make sure that you are spelling correctly the same way that you created above here. If you are spelling correctly, it could be that you actually forgot to run this piece of code here. So if you forgot to run, you don't have this object in your environment yet, and that could be causing it. Were you able to find it?
It says error in mutate SOIK3 rep equal case.
Okay,
Caused by error in case.
let me stop
And-
sharing because maybe you have an error lingering from above in your code. So let me stop sharing, then you can share yours and we can go through it together.
Can you see it?
Yeah. Okay, so let's see, I'm just looking at your code. Can you, so if you have your cursor on line 73, just have it there and then anywhere in line 73, and then push command return or control enter depending on your operating system.
Yeah, I just did.
Okay, I think I know what's going on here. I would just give it a quick second to see if anyone else can spot it. This is a good, every time we have issues, these are good exercises for us to kind of train our brains to troubleshoot code and see what's going on. So I'll just give here 10 seconds if anyone can spot what's going on and jump in.
I guess we haven't, in the 75th row, we had to add additional information,
And what is missing there?
less than 200.
Yes. So I think Kumar got it. Did you understand that, Rolando?
Yeah. So that would be here, right?
That'd be 200. Yep. So I think you were just missing that. If you try to run it now, it should work. Yep. So that worked. And then if you can run that to print it so we can inspect the changes. And then you can go to the next chunk and because you had an issue on the previous one that was creating soy K4, then soy K5 wouldn't work because of that lingering issue. But here, now it should work. So if you run this chunk now, it should work. Yeah. Awesome. Thanks, Kumar. Appreciate your help.
Thank you.
Thanks, Rolando. All right, so let me share mine back again. And let's keep going. Okay, so again, now you can notice that we have 64 rows instead of 16. That's because we pivoted longer these columns. And you see now that we have this new column called location.k, where now we start having a column where we have the location names under them. And we also have this column called kpct where the actual values are. And the reason for location k and kpct is because of these arguments that we changed above here. And then we basically pivoted longer those values. So again, this pivot longer is when you want to go from wide to long. There is also the counterpart of that when you want to go from long to wide. So imagine if we wanted to undo what we just did, we would use the pivot wide function instead of pivot longer. It follows a very similar logic, but this is very useful in our case, because now we have a column where we have the location names, even though they're not finalized yet, but at least there's somewhere that we can play with them. All right, so if you come here on the next chunk, we're going to use this function separate. So what's going on here now is that our location.k column has basically three components here, right? So, or I mean, really it has the site location that's important for us, so Tifton, but then it has this underscore kpct that I really don't care for anymore. Because now that information is in a new column. So if I wanted a column to have just the location names, I don't need Tifton, or I don't need kpct anymore to come along with Tifton. There are different ways for us to fix that. I want to show you one of them that also is one of the functions that I think are very useful in data wrangling. That's called separate. So come here to the soy k_6 object. Let's give it the assignment symbol. Let's call this function separate. As you may be thinking already, the first thing we give it is the incoming dataset name. So that's soy k_5. That's the latest version we have just created above. I want to break line here just to make it easier to read. And then the first argument here that it gets is what column are you trying to separate components of? So that column is right now called location.k. Remember, I want to separate location name from that kpct. So the column that I want to separate is location.k. I want to give it a comma, and I want to break code again, and it has this argument called into. So if you look at this, the values under location.k, they have one common separator, which is the underscore, right? And all of them have the underscore here. So if I ask to separate this column, R is going to look into this column and realize there is only one common separating value that is underscore, and is going to basically clip whatever you have an underscore and then create a new column for each one of these components. So right now, if I separate this location.k, it's actually going to create three new columns. One is going to have the first component here that's actually the location name. The second one is going to have the word K repeated for all of them. The third column is going to have the word PCT repeated for all of them. Because I have these three pieces, I need to give it three new column names for those pieces to fall under. And that's what we do here in this argument called into. So we use here the C function because we're given three values. And then within quotation marks, I want to give the first column name. I want that to be called location. I get outside the quotation marks, give it a comma, open and close quotation marks again, and give the second column name. I just want to call that K, add a comma, and do one last time for the last one that I just want to call PCT. So this is how your code should look like, where we're separating this location column into three components that are going to be stored in these new columns called location, K, and PCT. If you run this, and then you print soy K6, that's exactly what happened. Notice how now we do not have a column called location K anymore because we just separated that, but we do end up with a column called location that has all the location names, a column called K, and a column called PCT. So now we finally have one column that has all the location names that we wanted, and it's just that name by itself. We don't have any extra added things as part of that location name as we just had previously before running separate. Okay, so always think of separate as taking some values that are under a column, using a common separator character, in this case was the underscore, and using that information to partition this into as many pieces as needed. That's also a function that I use commonly when I'm doing data wrangling. All right, let's go to our next chunk now. So what happens now is if you see at the current stage that we are in, so soy K underscore 6, which is printed right here. So, you know, we have some columns here that we actually don't need anymore. So for example, I really don't need to have this K column or this PCT column, or even the pounds per acre, the rate in pounds per acre, if my goal is to create a figure in international units, or even like treatment number or stage. So those are all things that came with this data that, yes, they're important. They're kind of like metadata to some extent, but really for an analysis or even for plotting, I do not need them to move forward. So I want to make a subset of only the columns that I will be using from this point on. So we kind of decrease the clutter here and how many columns there are in this data frame. So to do that, come here under soy K7. Let's give it the assignment symbol. And the function we need is called select. Now, one point I want to make here that is something that has bit me already many times, and I know a lot of people go through this, is that right now we want to use the function select from the package dplyr. And I know that because I've been using it and I'm telling you that that's the one we need. However, especially for this function here, select is a very common function name across many packages. Sometimes you may load a few packages that each one of them has a function called select. And if you come in doing data wrangling and you think you're using the function select from dplyr, but actually that function is coming from another package that does not do the same or does not have the same functionality, you will start getting errors and errors and errors, and you don't know what's going on. And until you finally realize you're using a function select from the raster package, for example, that does something else than the dplyr select. And again, I'm saying this specifically for this function select because that's the one that I had the most trouble with in the past, as far as thinking I'm using from the dplyr package and it's coming from a different package. And what I do to avoid that to happen, and I just want to teach you how you would do that. So if you have a function you want to use and you know exactly what package you want it to come from, especially when you have those types of conflicts, you can specify the package name. So this case would be dplyr, and then you use the colon symbol like that, and then the function name select. So this way you're saying, I want to select function from the dplyr package. That's a way to say that. Just wanted to expose you to this because, again, if you ever run into issues of a select function that you're using for data wrangling and you're getting errors that make no sense, this could be the reason why. So using that dplyr colon select helps to avoid these issues. So the first thing that we would do here is call the object coming in, which is soy K6. And then I just want to break line here to make it more readable. And then, you know, if I just go up here, I just want to maybe walk you through my train of thought of what we actually need, what columns we actually need in this data to keep moving forward. The plot number, I mean, it's useful as metadata, but we don't really use it in an analysis. So we don't really need that. The treatment number, if we did not have So here the treatment number is basically matching the potassium rate, since that is our treatment. So all the zeros are treatment 1, all the 50s are treatment 2, and so on. So if we have the actual treatments that were applied, we don't really need a treatment number column either. The stage here is the same value across the whole data set because it was measured only once. Therefore, we also don't really need the stage column moving forward. Potassium rate in pounds per acre, if our goal here is to keep only the international units, we don't need the potassium pounds per acre since we already have a transformation of that in kilograms per hectare. So I do want to keep kilograms per hectare here in the select. So I'm just copying and pasting that here. The rep is going to be important as that we're going to be using for modeling purposes. So I want to keep the rep as well. Location is also going to be important. We went through all this trouble to create this column. So, you know, because we had a use for it. So let's keep it in our data set. And because, I mean, we could paste location here, but this is also taking the order. So it's going to bring in this order. I like having location as the first column we're bringing in, just because that is the highest level of hierarchy. If you think of it, you have a location where on that location, you have blocks and you have plots and so on. So location being the first one, then potassium rate kilograms per hectare, or rep information. And then we do not need this K column. We do not need this PCT column, but we do need the KPCT column because that actually has the values of what was measured in this study. So these are the columns that we want to keep moving forward, right? And we're using the function select from the dplyr package to do that. So if you run this, I had a typo here. So, you know, one thing I just want to walk you through. Errors happen all the time. I make errors. You're going to make errors for sure, especially as you're learning. It's always good to kind of read the error message and see if that helps you. Sometimes it's not helpful. In this case here, it kind of is, right? Because it's saying object soy K6 not found. So either I misspelled soy K6 or I forgot to actually create this object above. In this case here, I misspelled, right? It was an easy way to fix it. I just run it again and now it works. So now we still have 64 rows, but now we only have location, K rate, kilograms per hectare, rep, and KPCT as we wish to have. Just want to stop for a brief moment and give anyone a chance to ask a question, raise an issue.
Yeah, I would like to ask you something. The way we were selecting right now, I was just thinking the intuition of mine was that I should write concatenate. I should write C here, but we didn't write. Why is it so? What would have happened if we would have wrote C?
That's a great question, Kumar. And to tell the truth, so a lot of times in functions from the tidyverse, they use this approach of not having to add a quotation marks. So this is a good case. You know, if you think of when we were doing the mutate, we also did not have to give the new column name or even the column we were using, or, you know, on the case when here. So we're not using quotation marks, and that's how it is most of the time within the tidyverse packages or functions from packages from the tidyverse. However, in some times we do, right? So this into we are giving this 3 ones here. And that's a good question because I guess I don't have a really good answer for you. It's gonna come down of, you know, you're trying something and if it doesn't work, I guess, you know, when you ask for help, you're gonna be able to see, or even if you see examples online of how to use these functions, you're gonna be able to see how they're used. A good way as well would be to use the help function. So if you do help select, it will show you examples on the documentation at the end. You can also learn how that behaves. Here, I have an impression that if we used, I mean, we can just quickly try here and see. I think this would still work. That's my intuition. I could be wrong, but we can try. Yeah, so this still worked, right? But I guess it gives you the option on not having to do that in this case. But that's a great point, and it's something that you're gonna, the more you do, the more you're gonna start realizing these patterns. Yeah, but that was a great point. Thanks for your question.
Okay, thanks.
All right, so we selected, yeah,
What do we need to do if we need to do the opposite, like we just done in 21 column that?
you mean like if you want to tell which ones you do not want to select? Is that what you're asking? Yeah, so Ujwal asked a very good question here as well. So let's say if instead of saying what I want, I could also say what I do not want. Sometimes that's easier, right? In this case here, I don't think it makes a lot of difference, but imagine you have a data frame again with like, I don't know, 60 columns, and you actually just don't want maybe 5, right? It's easier to say, I don't want these 5 than saying I want this 55, right? So in that case, if you want to say what you don't want, you can just use the minus. So let's say if I actually, if we just do a quick, I'm just gonna comment this part off so I don't delete it, but it's also not interpreted by R. And I just say here, if I don't want, let's say, plot, I think we can just do like this, add a comma and treatment. Let's try this first and see if that goes well. Yeah, so you just give it a minus and then you just keep adding commas. So that's how you would say, I do not want these columns, but I do want everything else, as opposed to saying what you want. Yeah, that was a good question. And really, this select function has many helper functions as well, that it could be like, you could select function that starts with a given character, that ends with a given character, or that contains a given character, as we saw on the contains KPCT. There's many other things like that that can help you select only columns that you want in a more, using a pattern that those columns have rather than just spelling them out. Another thing that also works here is if you want a range of columns. So let's say in our case, I think we don't want like an easy range, but let's say if I just print soy K6 here, if I wanted from plot through K rate kilograms per hectare, I could come here and just use the colon notation. So plot to, well, let's say plot to rep. So plot, everything between plot and rep, I want to keep. You can use this notation that we already learned about. So that would also work if those columns are consecutive, right? All right, I just want to delete this just so we come back to where we were.
And can also do by column number.
Yes, we can also do by column numbers. I think in that case, let's try. So these columns have names, but they also are in the first column, second column, third column, and so on. So we could say 1, 2, 5, for example. Yeah, so position as well works. Yeah. And I'll share with you some more materials in case you're interested in learning more about these functions, which again, I'm showing you one example of how to use them, and I'm exposing you to what these functions do, but really they have many more options you can explore, just like what we're doing right now. And whenever you get to a situation where okay, I know I have to use this function because I want to select a few columns, but I don't want to be typing, or I want to, all the questions you're asking me right now are things you can ask Google. For your whatever situation you end up having in the future, and you're going to get an answer. And these functions are really powerful. So but this is great. It's great questions, great conversation, because it really shows me you're thinking about this and how you can use this differently. And that's really the goal. Is I show you here one example, but really, your learning is not, it's going to be something that you also explore on your side. So I like that you're all thinking about these different ways. All right, so coming back to the exercise here, we just selected a few of the columns. The next one here is very simple. It doesn't really change for your data for modeling or even plotting purposes, but is a good function to be aware of, which is the function arrange. So let's say right now I have all my locations, like kind of like the plots from each one of these locations are all mixed, right? So I have Tifton, Midville, Washington, Macon, and so on. So let's say if I wanted to have all I think in this case it may be Macons, because it would be in alphabetical order. So if I want to have all the Macon observations together in this data set, and then the Midville, and then the Tifton, and then Watkinsville in alphabetical order, we can use this function called arrange. So if you come on soy k_8, you give it the assignment symbol. We're gonna use this function arrange. You can kind of think of this as sort, right? So the first thing, as you may be thinking, that we need to give it is the data set coming in, that is soy k_7. And then we're gonna say what column we want to arrange by, which in this case is location. So you just go and say location, and you run it, if you print it, now it has arranged all the observations by the column location, where it is arranging in alphabetical order. So it has all the Macon observations first, and then the Midville, and then the Tifton, and then finally Watkinsville. We could have arranged by any column, right? It could have been maybe if I wanted to have all the blocks grouped instead of location, you could just say rep. You would also arrange by rep, right? So now it mixes everything else, but it has all the rep ones together, right? So this is the concept of arrange. And if this, so as you see, it is arranging in ascending order, so going from smallest to highest. If you wanted the opposite, so the descending order, so highest to lowest. So let's say if I wanted the reps 4 to be on top and then 3, 2, 1, I would just add this function called desc for descending, and run that, and that would give you the descending order of that column. I don't think I tried using the desc function with a character column like location, but we can try. I'm assuming it's just going to do the inverse of the alphabetical order, so from Z to A. Yeah, so that's exactly what it did. And this step here, again, is not going to change your data in a way that's meaningful for analysis or plotting, but at least for you to visually see this data organized by a given column that makes more sense to you, you can use this arrange function. So I just want to leave it as location like that, because I like that idea, but here is a place where you can do whatever you want, because it's not going to change what happens next. Okay, now finally, so here's a question that you probably will face a lot of times when you're working with data. So let's say that I wanted to extract the means of potassium concentration by a given column. Any of these columns would be, even combinations of these columns would be fair game. Well, let's say I want to do that, maybe start off with that by location itself. So I want to know what was the mean potassium concentration in each one of these locations. Okay. So basically I have 4 locations. So what I'm looking for is a data frame that's going to have 4 rows. So 1 for each location with a new column that's the mean for that location. That's what I'm looking for here. In deep wire terms, we need 2 functions to do that. And I'll show you here what those are and why we use 2 functions. So the first one here on soy K9, what we're going to do is give it the assignment symbol. And let's use the function group by. As usual, the first argument here is the data set coming in, which is soy K_8. I give it a comma. And then we need to say what column we want to group by, or what column do I want to extract some statistical information based on the levels of that column. So that column I want to propose that for this exercise to be location, right? So before I run that, I just want to run soy K8, which is the incoming data set first, right? So soy K8, it's a table with 64 rows. If I now run the soy K9 and I print soy K9, notice that number of rows has not changed yet. I still have 64 rows. Now notice it is still a table, but now I have this new classification here that it has groups. So it has 4 groups based on location. So what group by does is behind the scenes, it sets up the groups that you want to extract some information from. But because we have not asked for the mean yet, or we had not asked for the median or the minimum or the maximum or whatever it is, it has not given us that yet because again, we have not asked for it. And just to show you again, if we get the class of soy K8, so soy K8 is the one before the group I. So it's a Tibble data frame, a Tibble, and a data frame. And if we get the class of soy K9, it is all that, but it's also a grouped data frame. So just to show you that behind the scenes, R has understood that you have some grouping that you're applying to this data. And now whenever you call a summarize function, is gonna do that based on this grouping that you just created. So now if you come on soy K underscore 10, give it the assignment symbol, and let's call the function summarize. As always, the first argument is the incoming data set. It has to be soy K9 because that is the grouped data set that we just created above. And now we can create a new column name that it can be named really anything. I wanna name this mean K underscore PCT. And then I give one equal sign because this is not a Boolean operation. I just want to say that whatever is after this equal sign is going to be assigned to that column. And then I call a function here. So because we're asking for the mean, it makes sense. We use the mean function. And I want the mean of what? So let me just stop for 1 second here, print soy K9, and let you all think about this. What column should I give inside of this mean function that I want the mean of? Neva, what do you think? KPCT, right? Because I want KPCT is the column that has the trifoliate potassium concentration, and I want to know the mean of that for each one of the locations. So yeah, thanks, Neva. So Neva said KPCT, that's exactly right. Now, one thing to notice, KPCT column has no NAs in it. So if we just say mean KPCT is going to work beautifully. If we had even a single cell that was NA, it would return NA. We talked about this in the intro class, and we already know how to fix this if it happens to you. But anytime you're using a statistical summary function like mean, median, maximum, minimum, standard deviation, any of those functions, always keep in mind that if you get an NA back, it's because you have an NA in that column, and to fix that, you just say NA.rm equals true. Okay, so if we now run the summarize function and we print it, this is what we get back. So we get 4 rows because we group by locations, and there are only 4 locations, and we get the mean of the potassium concentration for each one of them. Awesome. All right, so this almost summarizes what all the wrangling functions. We got to the end of them, but now I want to show you something that we're going to be using a lot in my course, and I use this a lot for everything I do in R, and especially data wrangling, and I'm sure you're going to be using this a lot as well. I don't think there is a very good equivalent of what I'm going to show you next in Python. I wish there was. But there's not. So this is one of the reasons why I like doing some of the things I do in R, is because I can pipe it all together. So introducing now the concept of a pipe. So a pipe is basically, so the first pipe that was introduced in R is the symbol % greater than %. This is a pipe. And it became so popular within R, and this was a package someone created, and it became so popular within the R community that actually the R software, so the people that make R, so not people that make packages, but people that actually make R, decided to incorporate this into R itself. So you don't need a package anymore to use a pipe. The only thing is that the pipe that it was incorporated into R is the symbol is different, but it does the same thing. So it is a vertical bar and greater than. So you can use either one. You know, I personally use the percent greater than percent because that's the one I learned first, and I became used to it. But if you see when you're Googling, you know, people may be using the vertical bar greater than. Those are basically the same. You can think of them as being the same thing. So what is a pipe and why is it so helpful? So a pipe takes, so let's say here, you know, if you have something on the left side, so let's say, I mean, you have a function, well, let me write outside of the chunk so it's not interpreted. So if I have a function, whatever function it is on this side, and then I do a pipe and I have another function on the right side of the pipe. So what the pipe does is it takes whatever it is on its left side and passes that as the data argument on the next function on its right side. And a convention when we're using pipe is to, every time you type the pipe, is to break code so things are like this. So you would be adding pipes and keep typing your code, add a pipe, return, keep adding your code, and so on. So basically the pipe is taking what's on its left and passing as a data argument of whatever is on its right. A very quick information here is that you would basically, so let's say this second pipe here is not just taking this function and passing to the next, is actually taking everything before it and passing as a data to the next. So it kind of carries forward different steps that you're doing on a pipe workflow as you move down the pipe. Okay, so what I want to do is to call your attention to what just happened up until this point. So we brought in SoyK, we apply clean names. We did a filter, but then we didn't keep this object. We returned to SoyK1 when we did the mutate to transform to English to international units. Then we use another mutate to create a case where we did a block, learning that from the plot. Then we pivoted longer to have the location as one column. And then we separated because we had some extra information that we didn't need. And then we selected, and finally we do the group by, we did an arrange, followed by a group by and a summarize. All these steps were sequential. I want you to notice how we were doing something, assigning it to an object, and this object became the input of the next one, and so on, right? So doing that in sequence. Before the pipe existed, and even if you think of doing this in other languages, you would do this. You would either create multiple intermediary objects that you really don't need them, because really my goal here in the end is to get this data frame. I don't care how, I care how I got here, but I don't need to be saving intermediary objects to show me how I got there. Because really the one that I want is this one. Let's say I want to export this table to have in a paper or something. So you would either create multiple intermediary objects like we did here, or even worse, you may actually combine all these functions and nest all of them inside of each other, which becomes a hell to really understand and really make sense out of that code if you're nesting so many functions inside each other. So none of them are optimal. So the pipe helps us to fix that. And what I want to show you here is how I would pipe all this together in one workflow. And this would really be what I would do in my projects. I never do the intermediate steps, but I showed you how to do them first so you can appreciate, I guess, how and when the pipe is needed and useful. So coming here on this next one, I want you to help me out. We have here 6 more minutes. I think we can finish this part at least. So SoyKW, and normally on my scripts, you're gonna see I bring a data, let's say SoyK, and then I always have a chunk that I have SoyK_W or whatever object name _W to indicate to me that that is the wrangled version that I then move forward using that. So this is a convention that I have. I think it's helpful to be aware of. So if you remember, we started off with SoyK. So let's do SoyK as the first thing. And as I'm telling you, we're going to be using the pipes instead. So here I add a pipe and I hit return. Now, what I want you to do is go back to, so if you're not seeing your outline here, you need to be seeing that. If you're not seeing it, toggle this on and off. You should be seeing on your outline the name of the chunks where we created each one of these objects. What I want you to do first is to go to the chunk SoyK1 clean names and just copy what is on the right side of the assignment symbol. So this, just copy clean names, SoyK. Copy this, and then on our outline, browse again to the piping it all together chunk, which is down here. So you gave a return, yes.
How did you get to the outline?
Yeah, so the outline, so there is, if you're not seeing it, it may be hidden, but there is this outline button here that you click on that and it should bring your outline.
Let's see.
You know, let me kind of.
This.
Yeah, okay.
The album, that's.
But there is one thing here that let me just come up to the podium again.
But it's not.
Yeah, so if your outline is not looking like mine, if you just see 1, 2, and 3, that's because when you set up your RStudio, there was an option, if you recall from the first class, that we selected to make our name chunks to appear on the outline. If you're not seeing your name chunks on the outline, is because maybe you didn't do that part of the first class. We could just go through that together so you can actually follow here along. That would be under tools. So if you come on tools, global options, let's see, I think that was under our markdown here on the right side, on the left side, sorry. And then right here, so show in document outline, you want to change this to sections and named chunks. Once you do that, make sure you hit apply and OK. And then your name chunks should appear on your outline, which you kind of need to have to be able to follow what we're doing right now. Okay. You got it? Okay. All right. So
I do have a problem. I'm unable to use the pipe, the code. It is not working on my R.
okay, so the pipe, I think you would be coming from the dplyr package or the tidyr package, one of those two. So try loading those packages and see if that works.
Okay.
But yeah, I just want to show you here the immediate next step of the pipe, and then if anyone has issues with getting that to work, you can speak up and then we can troubleshoot that quickly here. All right, so as we have done then is we started with SoyK, add a pipe, hit return, and then we went to that SoyK1 chunk. We copied what was on the right side of the assignment symbol, so the clean name SoyK, went back to the piping it all together and pasted here. One thing to notice though, that you're gonna have to change is the pipe is already taking what is on this left side and passing it on to as a data frame argument of whatever is on its right side. Meaning that we don't need to say SoyK here. It's already implied, and I think that even if you leave SoyK there, it may give you an error. So if we just do this and print it, this is basically the first step of applying clean names. Kumar, if you try running something, so if you have a pipe and you don't have any functions afterwards and you run it, it will give you errors because the pipe is expecting something after it. So if you leave like an open pipe, I guess, is going to give you an error. So after you added the function here, did you still have issues? Did it still give you errors? Sorry, you're muted. Yes, go ahead.
Okay.
Did it work?
No, while someone else is sharing the screen.
No, I mean, I was just asking, after you added the clean names, did
No,
it still
it is
give you
not
error?
working. No.
Okay, so let me just do this. I want to stop right here for now, because we're almost at the hour. So I just want to go on GitHub issues, open an issue for attendance. Make sure you do drop your name there for claiming your attendance for today. I will still keep going on this video just another 5 minutes just to finish this chunk here. I do ask that you take the time to watch the recording that I post right after the class, so you catch up at least with the end of this piping it all together chunk. And make sure you go through that and do that on your side before next class, which is going to be on Friday. Okay, so 2024 PPA. Issues, the new issue. Attendance, January 17th. Please go ahead and claim your attendance if you are in class. Don't forget to claim your attendance, because I will most likely not accept your attendance request if you drop your name afterwards, after class. And then, okay, so Kumar, let me allow you to share your screen. We can, so just to say, if you need to leave, you're welcome to. I'm not, at this point here, we finished the class. I do ask that you watch the recording later, just maybe 5-10 minutes after this. We're going to be done. I just want to finish this chunk here. You're good to go. And I'm just gonna, if you want to stay, if you want to watch until the next 5-10 minutes, you are also welcome to do so. So the assignment here is not going to be due today because we haven't gotten to that point. So we're going to have that due, or we're going to have that, I guess, presented to you on Friday, and then it's going to be due on Monday. Okay, Kumar, let me stop sharing. You can share yours. And again, if you all want to leave, have to leave, you're welcome to, but if you want to stay, you're also welcome to. Okay, so what is going on is basically, I think if you delete rows 143 and 144, remember that that is being interpreted by R and is giving you errors because of that. I think now it should work if you just run that. Yeah.
Yeah. But I saw you doing it without even putting anything, so I thought it might work on my screen as well.
Yeah, on my side, I was writing outside of the chunk. So remember that you can have narrative here. So I was writing here.
Okay.
Yeah. So that's why, like, this is not interpreted by R, right? So that's why we don't have issues.
Okay.
Yeah.
Thank you.
Yeah.
Doctor,
Yes.
so when you said this piping, so I have an error here. And then, so this one, you said all the steps that we did that were sequential. If you do the piping, it wouldn't affect, because we have the original data that you gave us.
Mhm.
So all those steps that we did, we could avoid them by doing the pipings to clear names.
Yes. I mean, we have not finished the pipe flow yet, so we did not get to the point yet. But once we finish this chunk here, yeah, we could have jumped straight to this chunk and avoid everything above. I mean, we're still
Now-
gonna be using all those functions, but it's just in a pipe, right? So we're really just avoiding the intermediate objects.
Do you mind, would you care if I share my screen to show you the error I had?
Yeah, go ahead.
All right, I don't know if you can see this, but this is on, I didn't stop it. This is on select, on
So
select, yeah.
the error has I mean, a lot of things going on, but it has something that can point us in the right direction. So what do you see there that can help us understand what's the error?
It says the K doesn't exist. The K kilograms per hectare doesn't exist.
Right. So the way that I would troubleshoot that is if you, so is saying this about the data coming into select, which is the soy K6, right? So the first thing I would do is to print on my screen soy K6 and see what columns it has. So if you just, yeah, it can even be this one here. Okay, so I spotted, I already know what's going on, but I'm gonna give it 1 or 10 seconds here to see if anyone else spots what is going on. And it is actually not on this chunk above, but I can already find the issue when you're printing it.
I know I didn't create the decimal. That's why you got a bunch of them. Because you say you don't have to do it, and I just keep on going with that. But is that the problem?
It's not. So I think,
Oh,
was
okay.
Eva, did you say something, or Renelisa? Okay, so Renelisa got it. So she said is the capital letter. So we have a capital K. So always remember, R is case sensitive. If you write a capital K and then afterwards you ask for that object or that column as lowercase k, it's not gonna work. So what you have to do to fix, I guess, is go up on your code. So you want to go wherever you created the K rate K kilograms per hectare. I think is one chunk previous. One more maybe. Yeah, keep going up in that. I think, let's see, maybe one more. So you see how something that happened very early was perpetuating your code. It was right here. So on line 66, you name K rate kilograms per hectare with a capital K. I mean, of course, if you wanted that to be the case, if you wanted to keep a capital K, you could. You just had to change all the other K rate kilograms per hectare to capital K everywhere else. That would work. But for you to keep in line with what we're going through in class, I would propose that you do what you did, which is change to lowercase. Of course, now for that to have an effect, you have to run all the chunks from this point downwards. So you have to run that chunk and then soy K4, soy K5, and so on. Oops. Okay, you want to hit return there to have your 3 apostrophes at the end of the row. And then you have an extra dot next to soy K3 on line 69. I think that extra dot is throwing you off. So now try to print it by Control Enter or Command Return. Yeah. Okay, so if you go to the next chunk, you can just hit the play button.
Here?
The other one to the right. Yep. That should work. Now go to the next one. You can hit the play button. It's gonna run that view and that's gonna open a new window, but that's fine. You can just close the window afterwards. So you can just go ahead and close that window. So on the soy K on the top, there's an X right next to it. So soy K underscore 5. Yep, right there. So just close the tab. Okay. Now go to the next one. Again, you can just run the chunk, but then it's gonna open that view function. Which is fine, but yeah, you can just run, yeah, you can just do that as well. So we're good. You can go to the chunk 7. Now that's gonna work because now, you know, the K array that you're calling now is in your data set. So you see how really something happened all the way up, perpetuated code, and it's having an effect. So now everything else should work if you just keep running until where we are. But make sure you do run until where we are.
Oh, I'm gonna run this.
And then soy K8 and 9. All right, I think there's a class here 11:30, so I just want to go back to finish this chunk that we're working on now. And then if you guys have any questions or issues, I can meet with you by Zoom after I get back to my office. All right, do you mind stop sharing, Rolando?
Yes, sir. Go ahead. Sorry.
You're good. All right, so I just want to, again, show you the intuition here behind what we're doing now is remember, the pipe already passes what is on its left as the data frame of whatever is coming on its right, meaning that we're going to have to delete the data frame arguments from our functions as we were using before. So after clean names, add a pipe, hit return again, and then let's go. So we can skip the filter because we did not keep using that object. So we can go to soy K3 mutate. So we can copy everything from the right of the assignment symbol, as I'm doing here, go back to the piping it all together chunk, and just paste it right below that clean names pipe. Again, remember, you have to delete this data set coming in because now the data set coming in is whatever is above that pipe. So all of this is coming into mutate. Now we're just gonna keep doing this and with all the functions that we're using here. So add a pipe again after the mutate, hit return to break the code. Now let's go to the soy K4. Let's copy what's on the right side of soy K4. Remember to get all the parentheses. Go back to piping it all together and paste it. Remember, you have to delete the data set name coming in because again, that's a job that the pipe is doing at this point. Go to the last, after the last parentheses of that mutate, add a pipe, hit return. And now we go back to soy K5, that's the pivot longer. Copy everything on the right side of the assignment symbol. Go back to the piping it all together. Paste it after the pipe. Remember now, delete the soy K4 data coming in pivot longer. Just gonna keep doing that until the end. I'm just gonna be doing and narrating what I'm doing so you can follow along, but that's what we're doing. So after the pivot longer parentheses, add a pipe, hit return. We go back to the soy K6, separate, copy everything to the right side of the assignment symbol, go back to piping it all together, paste it there, delete the data set coming in, add another pipe after separate, hit return. Now we go back to soy K7, that's the select, copy everything on the right side, go back to piping it all, paste it there, remove the data set coming in. Add another pipe, hit return. Now we're gonna go to soy K8 on the arrange, copy what's on the right side, go back to piping it all together, paste it there, remove the soy K7 from it, add another pipe, hit return. Now we go back to soy K9 and 10, where we had the group by. So we first copy the group by, go back to piping it all together, paste it, delete the data frame name soy K8, add a pipe, hit return. Now the last one, well, let me see. I think my plan was to go all the way through. No, actually, you know what? We can stop here at the arrange. Yeah, so we can stop at arrange. So I don't want to summarize this data because, you know, this would be the data you would use for modeling afterwards. So we don't want to summarize it. So let's skip the group by and summarize and just stop at the arrange. So I basically went back to all the chunks, copied and pasted what was on the right side, copied that from there, pasted here, in connecting all of them by pipes. Okay, so if we go ahead and run this, to know you were successful, you have to have your pipes after all the functions that we were using. And remember, you have had to remove the data set name from all of these functions. If you run that, you should be successful. If you print it, then soy KW is exactly the same as soy K8 actually. To test that, we can use this identical function. If we run this, it would come back as true, meaning that every single row, every single column, every single cell on these two data frames are exactly the same. And I'm gonna stop here. We can finish this up very quickly next class. And then we can go from there. Yeah, well, you know what? I mean, we have just a few moments before the next class comes in. So maybe we can just finish here. There's just one more chunk, and then I can give the assignment and I'll send an email to everyone to be aware of this. So let's say that this was the script that we used to wrangle a data set that's now ready for plotting and analysis. We want to save this version to file, to save something to file or to create a file on your disk with this data. we would use a write function. So we use here write underscore CSV. We need to say in CSV because that's the file name that we want to export. The first thing we give here is what is the object that we want to export. So that's soykw. And now we're going to give a path. So open and close quotation marks. We need to get outside the code folder. So for that, we do .. If you hit tab, now I want to come inside of the output folder, and I want to name this soybean underscore processed. And here we also need to give the extension, which I want it to be a CSV file, so .csv. If you run this, you should be successful. And just to make sure that, just to make sure that this worked, you would come here on your project, click the R blue button to see the main folder of the project, go under output, and now you should see a soybean process CSV in there. And then the assignment, I'll tell you more about this, but basically, I mean, you can just read here and it's going to make sense, but I basically want you to do a similar pipe workflow as above, but I want to know what is the average potassium trifoliate concentration for each potassium rate within each location. And I give you a tip here on how to do that. You don't need to show me your actual pipe workflow. I just need to send me a result. It could be a copy or even a screenshot of the final data set. You can send me that by email by next class. And I'll send more details in the class listserv as well. All right. Sorry, we're really late, but thanks for everyone that were able to hang around. If you have questions, I'll be in my office. I can help you, and I'll send you email and post the video shortly as well. Thanks, everyone.